Hey Wizard, I know it's been a minute, but I want to take you behind the scenes here to show you how we can tap into the mempool to take advantage of transactions before they happen. So in recent videos, I covered front running and how to protect yourself from front running in crypto trading using something called submarine sends. So for those who watch those videos, you will have a very, very solid idea of what I'm talking about here. But for those of you who aren't very familiar with the pending transactions, say on the Ethereum blockchain or the Binance Smart Chain, let's just do a very quick recap. Firstly, transactions go to a pending area before they get stamped into the blockchain. Because this is a decentralized system, we all have visibility to see those transactions. Now, as you know, there was a huge boom with the Pepe coin, right? This is a meme coin. It exploded in value and bots were making tons of money. I'm going to show you how they were making tons of money. So the first thing over here is we have this Pepe the Frog over here, right? This is a relatively small transaction, but let's say that somebody sends a large transaction here into this pending transactions area. Now that transaction might get discarded because maybe it's invalid, it hasn't got the right information in it, or the user doesn't have the right balance in their account. So sometimes transactions won't make it into the blockchain. But sometimes they do, and some traders have a lot of money. They're moving a lot of size around, and that size does move price, particularly in crypto. So we can literally see the volume and the value of transactions coming in that haven't yet impacted price. Now, you can't do that in traditional markets unless you are a crooked exchange, etc., where you can front run transactions and you're doing some corrupt trading, which is completely illegal. But here in crypto, everybody has the same visibility. So this is a new paradigm. And what I want to show you here is what this looks like in real life. You'll see here, I'm actually going to show you a flood of transactions coming through in a minute. But I want to show you what this looks like in real life. But the first thing is, let's say that you're trading 0.1 Ethereum, right? About $200, and you're buying this meme coin. And that $200 will have a tiny little impact on price. But now let's say you're trading, I don't know, 200 Ethereum. You're going to see that that will have a much larger impact on the price, right? So it's going to move the price. It's going to eat into the liquidity. And unless people are putting more liquidity onto, say, into these pools, or they are selling that token, so they're changing, what coins are held in terms of liquidity, that price is going to move. And if you can see that it's highly likely going to move, and it's going to move by a lot, you have an edge. One of the edges is, for example, you could go and trade on a centralized exchange like Binance. You could say, okay, I know because I'm watching this pending transactions area. I know this is going to move price a lot. So all you do is go and trade it on an exchange that would likely get arbitraged. So for example, here, if a large transaction is going through, it's going through on Uniswap, what's going to happen is Uniswap is going to get this big price difference to, for example, Binance. And one of the ways that price gap will close is traders will go and arbitrage that on Binance. So what you can then do is jump onto Binance and get in before that arbitrage gap closes, as an example. Now, this is not new information, right? Traders have known about this transactions pending area for a long time. There is a whole auction process that even happens where searchers find transactions and sell that information, etc. But the point here is we can gain an edge here. We can see large transactions before they happen, and they are going to move the market. Now, if I was to tell you, you can see that, would you choose to, or would you choose not to? Right? Obviously, you want to know. Yes, I want to see if a large transaction is going to move the price. And so that is what I want to show you over here, is how do we detect these transactions? Now, one of the ways that people try to do it is they will say, connect their JavaScript application to, say, an Infura API, right? So if you're a programmer, what you're doing is you're basically connecting in saying, right, let me see all new pending transactions, and then you will decode those transactions and see what they look like. So for example, let's go over here to Etherscan, and what I'm going to do here is just go and run these transactions just using a normal Infura node. And then in a minute, what I'm going to do is run it using my own full node on Ethereum. So I've got a node running on the blockchain, and I'm going to show you the difference. And then I'm going to show you how I filter the transactions. So the first thing over here is if I go and run this, you'll see here come the transactions, right? They're flooding in over here. All right, that's run enough. Let's stop that now. And let's grab some of these transactions and just enter them in here. Now, this is what's interesting. This transaction has been around 17 days, right? Let's try another one. Some of them are good. Some of them won't be good. It's a bit hit and miss. This one here, 12 days. Okay, so we're getting some pretty rubbish transactions coming through here. This one, 6 days. Like, some of them are great. Some of them you'll see are like, you know, from seconds ago, but even then it's just too slow. Okay, none of these are looking particularly great. All right, so here what we're doing is we're running our own full node now, right? So I'm going to show you what this actually looks like when you do it directly on the blockchain. And just to show you here, we can run some commands and I'll just say, you know, eth.block number over there. So we're on 171789994. Let me just refresh Etherscan over here. Yeah, 8994. So you can see that we've got the latest block. This is fully synced. One of the things, by the way, you can do to check if it's fully synced is just go eth.syncing. And there we go, right? So this is a full node. It is synced up to the blockchain on Ethereum. And we can now go and listen for and decode those transactions. So what I'm going to do here is go cargo run and run this process. Cargo's Rust, by the way. Now, just by the way, look at the speed of these. So these transactions are absolutely flooding in right now. And over here, I'm just printing out any transactions that should have a larger than say 1% or 2% impact on price. Here you can see, here's one from Wrapped Ethereum, and it's going over here to Weifu coin, Wrapped Ethereum to Elon coin. And this is not flooding in. This information is not flooding in because it's analyzing all of these trades, right? So all of these transactions, every single one, it's saying, is this on Uniswap, right? Is it on V2 or V3, whatever? What is the size of the transaction and what is the impact that will have to price? And then if the impact's big enough, it's going to print out over here. One of the things just to tell you is I'm looking to pipe this information in for the wizards. So to open an open socket connection for them so that they can get this pre-filtered information like directly whenever they want, whether it's in a chat window or in an API. This is one of the things. But it's pre-filtering these transactions and it's saying, okay, you know, this one here, it should be over 1%. This one here is over 4%. So WETH to ETH-IX, etc. And it's telling you, it's like the best indicator you can have, right? It's telling you ahead of time what's coming in. And so this is very exciting and I'm really enjoying working on it. Now, if we just stop some of this over here, copy some of these transactions in. Yeah, we can see that was 5 seconds ago. And by the way, you do get old transactions in here too. I think the longer you run it, the better. There will still be some old transactions, but you can see here, it's much more reliable than the one we were using. And this is not a stab at Infura, by the way. I love working with Infura's APIs. I use them all the time. But the quality of information I'm getting by running my own full node is far better. Now, I did want to take a moment here to thank somebody called Ash. So Ash interned with Crypto Wizards. He actually contacted me like a year ago, interned with Crypto Wizards and worked on a lot of information on the back end and actually taught me a lot from his own experience on some of the tricks and things you can basically deploy when running your own full node. Now, you might have looked into running your own full node and you might not have. If you've watched this video and you're thinking, cool, I'd like to run my own full node, here's some things to bear in mind. 2 things are really important, right? Having a really good networking connection, like internet speed, and the other thing is storage. So there's a lot of data that gets written when you're running your own full node. So full nodes are very expensive if you rent them. I'm renting this one. It costs a lot of money. Obviously, thanks to the wizards, we can now afford to do this. So as our community is growing, we're getting better toys to play with, and it's really exciting for me. But the point there is you can do it. You can do it on AWS. I think my AWS one, when I did it, was like $450 for the month or something like that. You can get things a lot cheaper as well. And also just a tip here, make sure your node is connected to as many other nodes as humanly possible. So that's something else you can do that can improve the quality of the mempool transactions coming in. Again, thanks to Ash, by the way, for that tip. That actually has helped a lot, but that's actually where it's at. Now, the other thing is you might be asking, why is this so much faster on your own node? And so one of the things I'll do here is just illustrate that for you. If you're running Infura, right? So Infura have their nodes, etc. And here you are, right? Here you're the circle. Here's the node you're connecting to. You're sending an API request there, and then that node that you're connected to is sending the response back, right? So there's this exchange of information. When you're running your own full node, it's more like you're like this. One of the other ways that I'm gaining an edge as well in terms of speed is instead of using JavaScript or TypeScript, I'm using Rust, right? So all of this code over here, it's basically using Rust to go and decode these transactions, etc. And it does it at lightning speed. I mean, it's faster than JavaScript, it's faster than Python, a lot faster than Python. And that's not to say I don't enjoy Python and JavaScript. I will still code in those. But just note that some of the courses that are coming out, I will be doing the programming in Rust, because if we're going to do something, let's do it right. Let's build it in such a way where you really understand what's going on, and you can have an edge over other traders, right? You can have a programming language where the execution is not only safer, but it's also faster depending on how you want to apply it. Like one of the ways you could apply that is if you're running your own Ethereum full node over here, and most people, including myself, they'll use something called Geth. Geth is built with Go. Go is a fantastic programming language, but you might have an Ethereum node running with Rust. And there's a new one being developed called Reth. I don't know how far in its development it is, but let's say you are a validator. You have your 32 ETH or whatever. You might have seen that blockchain hack that happened recently where someone was out of pocket like $20-something million because someone who was the validator could propose the next transactions, and they ran the front runner. It was really interesting. If you want me to do a video on that, I will, talking you through how they achieved that. But one of the ways you can do that, if you know Rust or Go, is you can go and edit the way transactions are prioritized on your client. And so there's a lot of things you can do there. Now, these are not things I really enjoy very much, so I don't really like the idea of that happening too much, because it means that this is not a fair playing field, really. And this is where I'm a huge proponent of blockchains like Solana. I think Solana, in terms of its architecture and in terms of how they thought about solving problems with their blockchain, is exceptionally good. And I've always been a big fan of Solana. So, there's things like that for me personally, and you may not agree with, and that's absolutely fine, but that's how I look at it. And so anyway, to bring this back, learning Rust has been really, really promising and really interesting as well. So I'm probably going to do some stuff on teaching you how to actually use Rust, but not just to use it for blockchain purposes. Until the next one, take care and talk soon.